Welcome to our AnyML video learning library. In this video, we'll walk through how to create a clustering experiment. Clustering is an unsupervised machine learning technique used to group data points into clusters based on their similarities. Unlike supervised learning, clustering doesn't rely on labeled data. Instead, it finds natural structures and groupings within the dataset. It's a core method in uncovering patterns that might otherwise go unnoticed. Clustering has broad applications across many industries. In marketing, it's used to group customers by purchasing behavior or demographics. In healthcare, clustering helps categorize patients with similar health profiles. In finance, it can identify groups of similar transactions or risk patterns. Ultimately, clustering enables better analysis, personalization, and decision-making through data-driven group discovery. Let's start by creating a clustering experiment. First, upload a tabular dataset. Then give your experiment a name. Since clustering is an unsupervised problem, we'll choose the No Target Feature option and select Clustering from the Problem Type drop-down menu. Let's preview the dataset. This dataset includes estimation of obesity levels in individuals from the countries of Mexico, Peru, and Colombia, based on their eating habits and physical condition. The data contains 17 attributes and 2,111 records that allows classification of the data using the values of weight levels. In the advanced settings, you can fine-tune aspects of the clustering process, like selecting the algorithms to be used or the desired number of clusters. Cluster optimization determines the number of clusters based on the best fit of the data. If you want to select a specific number of clusters in the output, turn cluster optimization off and select the number in the box above. If you're new to clustering, we recommend starting with the default settings. Once everything is configured, let's launch the experiment. The processing time depends on the dataset size and complexity of the selected options. Once your experiment is completed successfully, you will see a leaderboard, which is a visual representation of your model's performance. This is the first step to choosing the best model to deploy. On the leaderboard, AnyML has generated multiple models using different algorithms specific to the clustering problem. We use our proprietary AnyML score to help you select the model that offers the best clustering performance. After choosing a model, the next step is reviewing the model report. The feature importance shows which features contributed most to the model's predictions. For a more in-depth explanation about each feature, click the AI Guide button. You'll get clear insights without the complexity of technical jargon. The cluster's information provides key details on each cluster's size and feature distribution. Each cluster represents a distinct segment of your data, with the values indicating its real and relative sizes. Cluster observations reveal key traits, like averages for numerical and date values or dominant categories for categorical features, all compared to the full dataset's distribution. This highlights how each segment differs from the overall population, making patterns immediately visible. The clusters created by AnyML are assigned numerical values. You can add alias names with more meaningful labels and a custom description for easier interpretation and reference by selecting the cluster and clicking the Edit icon. Alias cluster names are saved and applied throughout the session and reports. The records for each cluster can be downloaded to a CSV file by clicking on the Download button. To learn more about each section, click on the tooltip by hovering over the icon next to the section name. A heat map is a visual tool that uses a color gradient to represent numerical values, allowing you to quickly spot patterns and trends. Use the heat map to analyze how features differ across clusters. The PCA plot visualizes clusters using principal component analysis, which reduces high-dimensional data into a lower-dimensional space for easier interpretation. Each point represents a data record, colored according to its assigned cluster. Use this view to assess cluster separation, identify overlaps, and detect potential outliers. To dive deeper into the data, click the Download icon in the top right corner. Here, you can examine individual records assigned to each cluster. If needed, You can create a new dataset that includes the cluster labels. Since different algorithms use different grouping techniques, each model may produce unique clusters. The AnyML score ensures you select the most effective model for your dataset. One of the most powerful features of AnyML is the scenario builder for model exploration and validation. There are two scenario builder modes in the clustering analysis: prediction and batch prediction. In the prediction mode, you can make predictions on new data with various models. You can enter feature values, and the application will provide the cluster it is associated with. In the batch prediction mode, you can upload a file with the same structure as your training data. Batch prediction also allows you to download your results to a CSV file. Clustering helps reveal underlying patterns and group relationships in your data without predefined labels. With strong clustering insights, you can drive smarter decisions and build more targeted strategies across your business. This concludes our guide of clustering experiment creation. To learn more about specific modules or features, check our video learning library. If you have any questions, explore our website or reach out to our team by email.